In this topic, we are going to be discussing about the pulse position modulation scheme. Pulse position modulation scheme. What is that? PPM, pulse position modulation schemes. Out of those three, this will be the best one which will be suitable. Why it is best, I will explain you anyhow. See. Now, first point in the PPM is, listen, in PWM signal, which is varying, we all know, in PWM signal, the leading edge of a pulse train is always constant and it is known to the receiver because which is coming at a regular intervals of time. Leading edge is known. What is unknown to the receiver, sir? The unknown to the receiver is trailing edge is unknown because width is varying. Trailing edge is unknown to the receiver. Leading edge is known to the receiver as it comes at regular intervals of time. Just a small question I am asking. Suppose if trailing edge is also known to receiver, then what is the thing? Try to pause the video and try to think about you. Anyhow, leading edge is constant, it is coming at regular intervals of time. Suppose if trailing edge is also known to the receiver where it is coming, then what is the thing in that? There is no information. Receiver already know what you are sending. Then what is the need of sending that? No information. Anyhow, in PWM, trailing edge is not known to the receiver, but leading edge will be known. It is coming at regular intervals of time. Now, in PPM, what we are sending is, students, in pulse position modulation, we are sending a short, constant amplitude, a short durated pulse we are sending at the trailing edge of a PWM signal. That itself is called PPM. So, let's see how the PPM signal, for example, above is the PWM. How the PPM signal is, we are sending a constant short durated pulse at the trailing edge of a PWM signal. At the trailing edge of a PWM signal. We are sending a short and constant pulse at the trailing edge of a PWM signal, that is called PPM. Are you getting my point? Here, amplitude is constant, width is constant. So I can say PT is constant. As amplitude is constant, it is having less noise effect. So when compared to all the three modulation schemes, this will be the better in terms of PT constant, noise effect also less. Are you getting my point? Noise effect also less. Now follow. Here width is small means I can say bandwidth is more when compared to those two modulation schemes. How we are generating the PPM signals are, first we are generating PWM and I will tell you the procedure. In that procedure, we are generating the PPM signal. Are you getting my point? And in the receiver side also, how PPM is detected? PPM is first converted into PWM and PWM is detected by using integrator circuit. That also I will show you. So first of all, I will show you how PPM is generated from PWM. So try to keep this is in mind. I am erasing it. And in the output side, in the last final, one more time, I will generate this. Are you getting my point? Follow. First we generated the PWM. How? By using the monostable multivibrator. We already know. Now this is given to the differentiator circuit. This is given to what, sir? Differentiator circuit, sir. Differentiator means just like a high pass filter you can. If the pulse train or it is having a step signal variation is given to the differentiator. Differentiation of step is a impulse signal. Where you will get the impulses are wherever there is a amplitude change. Amplitude change means final value minus initial value. Right side value minus left side value. Are you following my point? If the change is positive, positive impulse, change is negative, negative impulse, you will get. Follow. And here, let me write with the another color. We are having a change, right side minus left side, positive change. So we will get a positive impulse, negative change, negative impulse. Positive change, positive impulse, negative change, negative impulse. Positive change, positive impulse, negative change, negative impulse. Positive change, positive impulse, negative change, negative impulse. Are you getting my point or not? Now, this is given to a diode. The diode I am designing in such a manner that it is passing only the negative pulses. So, then what is the output? You will get negative pulses. And all these are given to where? All these are given to monostable multivibrator as a trigger. Those are given to monostable multivibrator as a trigger. What is monostable multivibrator, sir? It is having one stable state, one unstable state. When it goes to the unstable state, whenever external trigger is given. So what is the stable state we are maintaining is 0, and the trigger is given. It goes to the unstable state and come back. Trigger is given. Go to unstable state, come back. Trigger is given. Going to unstable state, come back. Trigger is given. Going to unstable state and come back. You can see that is nothing but a ppm signal. This is the procedure. This is the procedure of generation of ppm signal from PWM signal. Now, in the demodulation side, what I told, sir? Demodulation side, ppm is first converted into PWM. PWM is detected by using the integrator circuit, I told. How we are converting ppm as PWM? Let's follow. From here, I will follow. So, already I am having the ppm. Now, how it is converted is by using the RS flip-flop, where at the reset button, we are giving the ppm signal, and for the set button, we are giving a synchronized local oscillator pulses at a required carrier frequency we are giving. I will show you. So, this is given to SR flip-flop. If you see SR or RS flip-flop, SR, Q, here will be the Q bar. What is this truth table? SR, Q, Q bar. For example, previously 0, 1 is there. If both are 0, same state or previous state, you can say. If set is given, so Q is set to 1, obviously Q bar 0. That is called set. If R is given 1, so reset. 1, 1 means set and reset both are not happen. Not a possible state, you can say. Are you getting my point? Yeah, follow. So I am having the SR flip-flop, or let me write the RS flip-flop, anything. R, S, opposite to R, Q bar, here is the Q. PPM signal, I am giving it R terminal. PPM signal, I am giving it R terminal. And here what is given is from the synchronized local oscillator pulses at a required rate we are giving. Synchronized local oscillator. Now output we are taking from the Q terminal. That Q terminal output is nothing but PWM. How that PWM is? Let's extend this. Now follow. Let's check previously, nothing is there. So we are giving the synchronized pulses, we are giving at a required carrier frequency. Yes. S is given means set. S is given means set. So set means output Q value is 1. And it is going on. Until up to where? Until up to reset is given. Here reset we are giving. Reset means it is becoming as 0. That is completed. Second cycle. Set is given. So it's becoming 1. When it will becoming 0? Whenever R value is given. Next. Third cycle. Set is given. Set to 1. When it is becoming a 0, when R value is given. Where R is available? At a PPM. At these short duration pulse. Next. One more time set. Like we are converting this PPM as PWM by giving synchronized local oscillator pulses at S terminal as well as at R terminal we are giving the PPM signal. How PPM signal is demodulated, sir? I told by using integrator circuit, sir. What is the integrator circuit? Integrator circuit is nothing but low pass filter only. How the process is going on is, students, there these PWM pulses are given to the circuit. The time of the capacitor or the charge on the capacitor is depending upon how much duration pulse is available. If pulse is available for more time, the capacitor voltage also more. Pulse is available for less time, the capacitance the charging in the capacitance also low. So the voltage across the capacitor is directly proportional to width of the pulses. That is nothing but we are getting our message. This is about the PPM, PWM. In the previous we already seen about PAM. Clear?